There we go. So tonight, I can take any questions that you want. Last week we looked at section 9.1 and 9.2, and I thought tonight we could, if you have questions about 9.3, and then we're going to skip over 9.4 and look at 9.5 coming into this weekend, and there are review videos on that as well that I posted. And 9.5 well, 9.3 is looking at how to add and subtract matrices and how to multiply matrices. And then 9.5 is looking at just another way to solve matrices. So by the end of this unit, you'll have Gaussian elimination, Gauss-Jordan elimination, and then Cramer's rule, which is using determinants. So really, 9.3, you're looking at how to multiply matrices because you're going to use that skill in 9.5 to solve for determinants. So that's kind of where the link that we're going. We're kind of taking a break from solving matrices, looking at doing operations, adding, subtracting, and multiplying, but the ultimate goal is to get to 9.5, where we are solving a matrix using Cramer's rule and determinants. So that's kind of how all the units kind of connect together. Andrew, you were the first to arrive tonight. Do you have any questions for me that you wanted to start off with?
No, I don't really have any questions that I think that will be useful. I'm just hoping that maybe some other people have some questions that might enlighten me. Um,
Sounds good.
I'm not having too much problem grasping them, but I am finding them kind of demoralizing because you
Oh,
spend a
don't.
lot of time and effort, and then you get the wrong answer and you feel like banging your head against the wall.
Oh, this unit is a character builder because it takes some of these matrices take 3 pages to do. And I had a question come in today for a matrice, and I'll tell you, the student did everything right except that there was one point where they dropped the sign. So the numbers were correct, but the signs were wrong, and because it was 3 steps from the finish, it messed everything up. But what I want to say about that is that when it comes to the pretest and test, we have shortened the number of full matrices that you have to do. I believe on the test there's only one full matrice, and I'm glad I'm recording it because if you do that matrice and you mess up, keep your scrap paper and take a picture of it so that you can send it to me in an email, and I can give you partial marks for just showing me on your matrice that you had the strategy correct, but your sign wasn't correct. So going into the test, and it is a take-it-home test. Just if you find that you have done that long matrice and you don't get it right, but if you can show me your scrap work, I can at least give you partial points on that. But you're absolutely right. Everybody's in the same boat that it is a frustrating unit just because it's not your regular 5-minute questions that you're solving. But in the test, we've really tried to not make it too that you don't come out of the test, just with bruises all over your head from banging your head. And TJ's written a couple of things. So TJ did have questions, Andrew. So we're going to put some up for that. Oh, TJ, the schedule is up, and we did. It goes between Wednesdays and Fridays, but if you look in the welcome unit, there is a schedule. I was just trying to get a few extra days out of for this matrice unit, and that's why we have a Wednesday, but I believe it goes back to Fridays after this next one. Let me just quickly go into NSCC. Andrew, oh, you see it. TJ is asking about test dates. I think on the Skype recording, students can't see what people are texting, so I need to remember to say what students are texting. So let me just quickly go into D2L and check that out. Math 1047. Content. Welcome unit. Schedule and deadlines. Yeah, so we're back to Friday deadlines for Unit 2, Unit 3, Unit 4, Unit 5, and then the only other Wednesday deadline is for our last Unit 6 on Wednesday, August the 2nd, and that's because our final day is August the 4th, and then I go on vacation. So I want to get everybody, completed 2 days before so that I can get marks in, and if there is any wrap up, tying up loose ends, we have 2 days to do that. And the weekend, usually if the last day is Friday, then my marks have to be in for that Monday. So TJ, it's really only this matrices Unit 1 where it ends on a Wednesday. Everything else is a Friday except for that last Wednesday of the first week in August. Yep, that's great, TJ. Awesome. And I agree, TJ. TJ is saying that my math lab is not the best tool for doing matrices, and I totally agree because in the end they only want the last three answers, right? And you can't show all the work that you got to get those answers. So that's, again, I'm just going to say it again, and I think I'll write this in a news post too, that when you're doing the test, write your answers out on scrap paper. That's a good practice anyway to do, so that when you go back and look over your test, which everybody can do, you can go back in after your test and review it and see what you got right and see what you got wrong. And you can always send me an email with your worked out so that I can give you partial points. Sometimes in my math lab, they get you to do steps in between so that you can get partial marks as you go. And sometimes with the matrices, you can do that, but most of them they're just asking for the final answer. So it means a little bit of extra work on your part, but sometimes a half a mark, a quarter of a mark can work out to a couple of percentage points too, which is great. So I'll have to remember both of those things. To always, after a test, you can always go over and look and see if my math lab is being too stingy. You can send me an email, and TJ knows, Andrew, you didn't have me last term, but I have many students that after a test will say, Lori, can you look at questions 4, 8, 9, and 10? I think I deserved extra points here. And then I go in and I take a look, and if it looks like you're on the right track, you just missed a sign or didn't reduce, I give extra points, and sometimes it equals to 5 percentage points. Sometimes it can be 10 percentage points depending on the test. So I realize that as great of a tool my math lab is for online, because of the instant feedback and the ability to help you solve things. When it comes to the testing feature, there are limitations. So I try and make up for that by the ability for me to go and review. So Andrew, do you have any questions about that being new to my class, or does that sound okay to you to go back? I'm sure you probably had that with Jordan, that you could email him and he'd go over stuff.
Yeah, you can, like once you get the results of your test back and that you're reviewing it, it's just like in my math lab.
Yeah.
You can ask your instructor about that particular mistake that you made. Like it happened to me several times, just with like with the set notation and stuff. You forget
Yes.
a bracket or something, and it gives it, it marks it wrong. But you've clearly done the math correctly. It's
Yes.
just you didn't answer it in the proper form or whatever.
Yeah, a lot of it was I would get students that they would say solve for X, and then they'd put X equals the answer, and they had the answer right, but because they physically typed in X equals, they lost their point. So I went over that, like something like that. So, and you're right, you can either write in your test, click on ask my instructor and send me the question that way, with a little blurb of this is where you think you could have had points, or you can just do it as an email and just let me know all the questions you want me to review. So I think with that, TJ, you sent me an email going over the non-square matrix to solve. Did you want me to go over that one? Okay, so I'm just going to pop that one up because that's a good one. Whoops. Oh, I just had it here. Where is that? There we go. Give me 1 second while I bring that up. Okay, let's see. There we go. And TJ, we still have a full, this is Monday, so we still have a full week and a half because your test isn't due until next Wednesday. So there's still lots of time to get through the last few sections. And as hard as the matrix unit is, I do feel like it's so well connected that it's not that you're having to learn a whole lot of new material that's not connected. They kind of build on the sections. So the work that you're doing in 9.1, 9.2, that good practice is going to help you learn the next unit, so it builds on it. But this is the one that you sent me. Use Gaussian elimination to find the complete solution to the system of equations or show that none exists. So first thing that you'll notice is that in this question you have three variables, x, oops, need that one, there we go. You have x, y, and z, but this is called a non-square system because you only have two equations instead of the normal three that you would have. So the first thing that you want to do when you're solving a system of equation in three variables is set up your matrix, and you want to make sure that your x coefficients and your y coefficients and your z coefficients all line up. So for my first I'm grabbing my pen here. For my first row, I'm going to have 4. That's my coefficient for x. My coefficient for y is positive 1. And I don't know why I'm making them so big, because I'm going to run out of room. Do it a little bit smaller here. There we go. 4, positive 1 for y, negative 1 for z, and is equal to 4. And then I have my second row is going to be this second equation. So my coefficient of x is 9, coefficient of y is 9, coefficient of z is negative 8, and then that is going to be my constant. So then, oh, I'm just looking at my notes, there we go. So we're missing that whole third row, and what that could mean is that that's going to be our z value. So z might be equal to any real number. What we want to do is get a 1 in that location, a 1 in this location, and a 0 in that location, and that's going to be our Gaussian elimination, is getting a 1 in where the 4 is, a 0 underneath it, and then a 1 across from it, and that's going to help us solve this this non-square matrices. So I'm going to go ahead and do that. I'm going to get a 1 in that first position, and that's going to give me so I need to, what am I going to do here to get a 1? Oh, I'm going to, what do you think I should do? TJ, if I wanted to get a 1 in that 4 position, what's going to be the row operation that I want to do? What am I going to do to row 1? I can't switch them, row 1 for row 2. Remember, this is row 1 and this is row 2 because of that 9. What I can do, if I want to change this 4 into a 1, is I can divide everything in that row by 4. Now you're not supposed to use division, so instead of dividing by 4, I'm going to multiply by 1/4, because multiplying by the fraction 1/4 is 1/4 is the same as dividing by 4. And if I divide 4 by 4, then that's going to give me equal to 1. So doing that, 1/4 row 1, I'll get 1/4 times 4, 1/4 times 1, 1/4 times -1, and 1/4 times 4. TJ, Andrew, does that look okay so far for that first row?
Yeah, that's how I would go about it.
Great, okay. My speakers went mute for a second, so I didn't know if I had lost you guys. And I'm going to change to, there we go. So that looks like okay, and now I find that it uses so much paper when you're doing these out, but that's okay. So I'm going to now solve that first row. So 1/4 times 4 is going to give me 4/4, which is going to be a positive 1. And then the second part here, 1/4 times 1 is going to be 1/4. And 1/4 times -1 is going to give me -1/4. And then 1/4 times 4 is going to give me a 1. And again, I'm making everything too big. There we go. And then my second row stays the same. So what I have done is I've gotten 1 into this position, and so my next step is to get 9 to be a 0. So my next operation that I'm going to do, and I'm going to do it over here, is I'm going to multiply row 1 by -9. -9 times row 1, and then add row 2. And when I do that, I hope that I'll get a 0 in that position there. So I have -9 times row 1 plus 9. That's going to be that first position for that second row. And then I'm going to go -9 times positive 1/4 plus 9. That's going to be in that position there. And then again, -9 times -1/4. So I'm working with fractions here, but that's okay. I'm going to tell myself not to freak out. And then I have to add that -8. And I have to make sure that because I'm adding, that I add a negative. So I'm making sure that I don't miss out on my signs, because that's important. And then this final one is going to be -9 times positive 1 plus 9. And then, so that's going to give me my final row is going to be, so I'm just going to solve for each of these or simplify and see what I get as my numbers across. So -9 times 1 plus 9 is going to give me 0 in that first position. -9 times 1/4 plus 9. So this one I'm going to have to do a little bit more figuring. So -9 times 1/4 will give me -9/4 plus 9. But I can't add those two together because they don't have like denominators. So I need to make them into equivalent fractions. So I need to take my positive 9 and make it over 4 so that I can add the two fractions together. So to do that, I'm going to say, okay, 9 times 4 is going to be 36. So 36/4 is equivalent to 9, because 36 divided by 4 is equal to 9. So I'm going to rewrite this so that I have fractions with the same denominators. So that's going to be -9/4 plus 36 over 4 because that's equivalent to 9. And that's going to give me negative 9 plus 36 gives me 27 over 4. So that's what's going to be in this second position here, 27 over 4. So my first position is 0. My second position is 27 over 4. Oh, and they're going to give me a little bit more room. That's good. So that was this one here. And now I've got to do this one. I'm going to do that one right underneath here because I need a little bit of room. This is another one where I'm doing negative 9 times negative 1/4. So that's going to give me positive 9 over 4. Subtract 8. So I simplified negative 9 times negative 1/4. Negative 9 times negative 1 gives me positive 9 over 4. And then I'm subtracting 8. So I can't add those together unless my denominators are the same. So I'm going to leave 9 over 4, but I'm going to multiply 8 by 4 to figure out what the equivalent fraction is for 8, and that's going to be 32 over 4. So 9/4 subtract 32/4 is going to be 9 subtract 32 equals negative 23 over 4. And that's going to be in my third position. And then my last one is this one. Negative 9 times 1 is negative 9 plus 9. So that's going to give me 0, which is going to be my last position. So I'm just going to rewrite the equation. Oh, TJ's. This is a short one compared to some of the questions that we have. TJ's just saying that it's a longer question, but that's okay. So now that I have my second row of numbers, I'm just going to, because this is so awfully written, I'm just going to write out what my new matrix looks like. New matrix, 4th to 1, and then I said that I now have 0 in that position. I have 27 over 4, and then I have negative 23 over 4, and then I have a 0 there. Okay. Andrew, you're right. There are no short matrices questions. Usually we don't do long questions on Skype, but I don't think there's any way to get around it, TJ. And this is great because we get to go through these steps. Now, because we've done fractions, it always worries me that I've done something wrong. I want to make sure that I'm okay. And I think that looks good. 9 plus 36 over 4, 27 over 4, and then okay, so far so good. I've got a 1 in this position. I have a 0 in this position. Now I need to get a 1 in this position, so 27 over 4. I need to change that to be a 1. So this is what I'm doing now. So I need to do a row operation that changes this to be a 1. So what I can do in this situation is normally when you have a fraction and you want to change it to a 1, what you want to do is you want to flip, multiply by its inverse, its reciprocal. Yeah. So that's what we're going to do. Okay. So if 27 over 4 is our fraction, then we're going to multiply it by 4 over 27. So I'm going to multiply it by 4 over 27. And this is what it looks like. 4 over 27, just to show that it will equal 1. 4 times 27 for the numerator is going to give us 108. And 27 times 4 for the denominator is also going to give us 108. So that's going to be equal to 1. So that's going to do it, but of course we have to multiply everything by 4 over 27. So for our row 2, we're going to have 4 over 27 times 0. And then we're going to have 4 over 27 for our second column. So 27 over 4. That's going to be this position here. And then in our third position, we're going to have 4 over 27 times negative 23 over 4. And then we have to do it again, 4 over 27 times 0 for that last position. And so that means our final row is going to look like this. 4 over 27 times 0 is 0. And then 4 over 27 times 27 over 4, everything cancels out. That's going to be a 1. That's going to be in our second position. In our third position, 4 times 23, negative 23. 4 times negative 23 gives us negative 92 on the top over 4 times 27 equals 108 on the bottom. And then and that can be reduced, which I'll do in a moment. And 4 over 27 times 0 is going to be 0. So that's going to be our bottom row, but I want to reduce this. So I'm looking for a number, the highest number I can, the greatest common factor that goes into them both. And 12 doesn't. So I'm just going to do trial and error. If you guys want to throw out something that works for both of them. I have negative 46 over 54, which I can then reduce even more. And then 23, whoops, negative 23 over 27, I believe, is going to be as reduced as I can go. TJ's giving me this thumbs up. So that looks to be the one. So my new matrices is going to be 1, 1/4, negative 1/4 is equal to 1, and 0, 1, negative 23 over 27, 0 is going to be my second one. And then, so now I've gone as far as I can go with, you don't have to get a 0 in this final position here. So once you get a 1 and a 1 and a 0, that's as far as you can go with your Gaussian elimination. And now you're going to set up new equations to represent what you have. So this first row here of row 1, remember that this is my x value, my y value, and my z value, and what they're going to be equal to is on this side. So that first equation is going to be x plus 1/4 y minus 1/4 z is equal to 1. In my second equation, 0x, so I don't have to write down that, but I get 1y subtract 23 over 27 z is equal to 0. So the next step, once you've gotten your two new equations, 1 and 2, what you want to do is solve for y, because that's going to give you your z value. Your z value is going to be equal to any real. So when you do your solution set of x, y, and z, z just stays as z. It's going to be z is equal to or a member of any real number. So we just leave z, but now we want to put what y is equal to in terms of z. So everything's going to be in terms of z. So what I'm going to do here is I want to bring the z value over to the other side and just solve for y. So that's what I'm doing. I'm solving for y. So that means I'm going to add 23 over 27z to both sides. That's going to get rid of it from this side, and that adds it to the other side. So I get 23 over 27z. That's what my y value is. So this is going to be 23 over 27z. That's going to be my second value in here and of my solution. And then I'm going to take my y value and I'm going to substitute it into this first equation to get what x is equal to, and I'm going to solve for x. So if I put in 23 over 27z in for y, I get 1/4 times 23 over 27z minus 1/4 z is equal to 1. So far, so good, guys? I probably
Yeah,
should. Yeah?
I'm good. I'm
Okay.
good. Those fractions drive me crazy, but I know they're necessary evil.
Yes. Well put. I'm trying not to freak out either. They're not my favorite things either, but you know how to deal with them. So far so good. And what I'm going to do is try and solve for x. So I want to put everything else over onto the other side. But the first thing I want to do is simplify this. So 1/4 times 23 over 27z. 1 times 23 is 23. Whoops. And 4 times 27 equals 108. And this is going to be negative. See, this is, I should have put that in the brackets. Negative, oh no, it's not negative. That wasn't supposed to be there. I am positive. This is positive here, and it was positive there, so I'm okay. So 1 times 23 equals 23. 4 times 27 is 108, so that's going to be 23 over 108z. And x plus that, I'm just bringing down the x, minus 1/4 z is equal to 1. And then I can combine like terms. So 23 over 108z minus 1/4 z. So I need to make like denominators. So I'm going to use 108. 4 goes into 108. How many times? 108 divided by 4 equals 27. So 23z over 108 minus 27 over 108, because that's 1/4. 27 divided by 108 equals 1/4. And all I did there is I said, okay, 108 divided by 4 will give me 1/4 of the 108. So that's how I did that. Z x plus. And then I get 23 minus 27 equals negative 4 over 108 z and it's going to be x is equal to 1. So I've run out of space and it doesn't seem to be going down, so I'm going to move over to this side and just rewrite that again. X plus, not x plus, x minus 4 over 108 z is equal to 1. And then I'm going to solve for x. So I'm going to add 4 over 108 z to both sides, and that will get x by itself. And 4 over 108, I can definitely reduce that. X is equal to, 4 goes into both 4 and 108, 1 over 27 z. So this is going to be 1 over 27 z is going to be my x answer. So definitely difficult, this question, TJ, because it has lots of fractions. The process for this is, first of all, that you have a non-square matrix. So that means that when you have 2 equations but 3 variables, you're only going to be able to set it up in 2 rows, but that's okay. And then from there you have to get to the point where did I have it at? Right here. Where you get a 1 here, a 0 here, and a 1 here. That's as far as you can go in terms of getting it into that row echelon form. And then once you get it into this form, you rewrite your equations using these coefficients. Z's going to be any real number, and you're going to start working backwards. But your answer is, which is here, you're going to have Z in your answer, which is fine. And then sometimes what happens with a question like this is they'll say, okay, now tell us if Z is equal to 10, what is going to be your X value? What's going to be your Y value? So if Z is 10, you're just going to input it in for the Z value and then solve for your X value. Great, TJ, that example, I believe I put that in the notes from 9.2. Oh, maybe I didn't. Do you know what? I have an example in on a slide, and I'll make sure that I post it to the news feed along with the review from tonight. So it's a different example, but it does go through how to solve it. So I'll make sure that I add this with the recording when I post it tonight after our session. So I'll write myself a little note for that.
I think there's a non-square example in the 9.2 review notes that you posted.
Oh, I did. That's because that's what I'm looking at, but I didn't know if I had that in. So perfect. So in the 9.2, thank you very much, Andrew.
Yeah, you're welcome.
Great. So I don't have to post that. There we go.
I mean, unless I'm dreaming that I saw it, but I'm pretty sure I reviewed it a couple days ago.
No, I think it is there because I'm looking from my 9.2 notes and I have it in, I think I'm looking at the same thing, so I think we're good. Great. I'll double check though, TJ, just in case Andrew and I are off. Oh, great. Nope, TJ says he sees it now, so we all concur. All three. Woot. Awesome. So have you guys started 9.3 yet? And don't worry if not, because really this week is supposed to be starting 9.3, so if you haven't started 9.3, no worries.
I'm on the very last question of 9.2.
Oh, good for you. Awesome.
I did a non-square question with 4 variables just before I logged on for this session here, and I got it right on my first attempt. I was very happy.
Yay! That's awesome. Great. I will not have questions with 4 variables on the test. That's for sure. 3 variables are definitely enough.
I got a 4 variable question in 9-1 wrong 3 times. I almost
Oh,
cried.
I know. That's not fair at all. How many, were there a lot of 4 variable questions in 9-1? Please say there weren't.
No, no, there was just one,
Just
but
one.
I still got it wrong 3 times, so there might as well have been
Oh,
four.
yeah, that's you're right. That's true. That might be something that I need to look at. Do you remember? You probably, Andrew, if you do get a chance, could you go back into that and just send me ask my instructor question so I know what number it is? Because I don't think anybody really needs to do 4 variable questions in my math lab. That's just mean.
I agree with you, but at the same time, all that practice and all
Did
that
it?
practice is that's what makes you, for me anyway, that's the only way I can get math is to practice, practice, practice.
Right. Yes, I guess. But man, that just it's hard though trying to persevere through all of that. And sometimes it's just hard to find out where your mistake is because it's such a small error that creates so much chaos after the fact, right? You get an idea of what NASA mathematicians really went through when they were trying to calculate like launch angles and stuff, and how there were so many variables that affected it that if they just had a careless error in one part of the calculation, it just throws everything off. Did you guys see the movie Hidden Figures about the black NASA mathematicians? If you haven't seen
Not me.
No, if you have, it's a really great movie with real math, and it's just interesting to see how they did the calculations back then when they didn't. This was pre-IBM computer, and actually in the movie they show the first IBM computer being brought into NASA, and what they did before that, which was just um, rooms with 30, 35 people in it, usually women, who were the calculators. They were the human calculators. Before a calculator was a machine, it was a human. So if you ever get the chance to watch it, it's really neat because it shows like real world math and what it takes to solve a problem. I mean, that problem of the launch angles and the speed took years and years to figure out. It was a cool movie. Oh, I see TJ's written something. TJ says that he had a friend watching him go through the matrices, and that was the spot checker. That's a great idea. Oh, yeah, I can clear the screen just a sec. A lot of pages of equations, that's for sure, TJ. Go ahead, TJ, put whatever you want up. It's all yours. TJ, I think, is off finding us a question, Andrew.
It must be a good one.
Must be. I hope it's not a long one.
The one thing I can say I like about the non-square matrices is that they are a little shorter.
Yes. Yeah, and once you know how to solve them, they're not as intimidating as they look. I think it's more of non-familiarity. It's like, oh, I just get the three rows, and now I have to solve it with two rows and have an unknown variable included in my answer is a bit worrisome, but it's not so bad once you do a few of them for sure. And then when you do go into 9.3 this week, you'll see that first of all it's adding adding matrices. So you'll have like a 2 by 2 matrix that looks like 3, 4, 8, 6. And then you're going to add 4, 5, 9, 2. And they're going to say, well, what's that equal to? And first of all, whenever you're adding or subtracting matrices, you have to make sure that they're the same order. And what the order means is just that they have the same number of rows and columns. So this is a 2 by 2. That's the order for that one. And this is also a 2 by 2. So 2 rows to 2 columns. And as long as they are the same order, oh, TJ has doubled himself. You can add them together, and what you do is whatever is in position 1 you add to position 2, and that becomes your answer. So 3 plus 4 will give you 7 in that position. And then, hi TJ, you cut out on us. 4 plus 5 gives us 9. 8 plus 9 is our next one. So that's going to give us 17, and 6 plus 2 is going to give us 8. So adding and subtracting, you're going to find, is super easy. Multiplying by a single coefficient is going to be easy. It's when you multiply by matrices that aren't of the same order that it gets a little bit complicated, but with practice it's not too bad. And hey TJ, so TJ's back. All right, I don't know what's going on. All right, so I need to add that one in? TJ, you didn't put anything on the board. Do you want a new board up? Here, I'll get you a new board. Okay, there you go. I was just giving a sneak peek while we were waiting for you on what's to come in 9.3. Adding and subtracting is easy. Multiplying by scalar multiplication, where you're just multiplying a matrice by one number, is fine. It's just when you're multiplying two matrices together, when they are of a different order, that's going to be the learning curve. But it's not too bad. TJ, are you going to just copy and paste in? Hopefully we don't lose you. Nope, it's not there. Is it from the My Math Lab? Do you want me to go in? Just let me know what number, what section, and the number.
I think it's there. Is that? Oh no, I just see the
Oh!
answer.
Oh wait, is
I
that
just
up?
see the
Oh,
answer
there it
there, not
is.
the question.
Oh, yeah, I see the answer too. Sorry. Here, I'll get rid of that one. Select all, delete. Oh, I just undid it. Sorry, because it was only the answer, TJ. We didn't see the question. Oh, same question we just went over, yeah. Oh, put up your answer again. Sorry, just okay. 1 plus. No, no, you're not confusing. And then I just delete 23 over 27. You're right. Okay, 1 over 27z. Oh, the 1 plus 1, what, 27z. TJ, yeah, why is it? Because that's what you put in is what we got, which is this right here. That was our answer, and it was 1 over 27z and 23 over 27. So we seem to have gotten the y value, but our x value is not correct. Yeah, I don't understand where the 1 comes from either. You have the final matrix that I did, where it was 1, 0, 1. Can you tell me, just read across the top for that final matrice where it's in this, what the numbers are, just because I've deleted and I can't go back, TJ? So it was 1. What was the number that goes here? 1/4? Great. And what was our second one? Was it the next negative 1/4? And then and 1, thank you. And then this one here. And then that one, if you could. Thank you. Thank you. Okay. Let's see if we can problem solve where we went wrong. No, I think that looks good. So in the end, our z is any real number, and then we found out that y is equal to 23 over 27z, and then we have 1x plus 1/4 y minus 1/4 z is equal to 1. So I was just taking this first row and rewriting it in with the x, y, and z. And then what I want to do is substitute y, 23 over 27z in for y, which will go here. So that's going to give us x. Oh, I think it's because of this 1 right here. X plus 1/4 y. Oh, sorry. I'm thinking ahead of myself. So 1/4, and then y is 23 over 27z minus 1/4 z is equal to 1. And then 23 times 1 is 23. And 4 times 27, I believe, is 108. Yes. 08z. Subtract 1/4 z equals 1. I have a feeling that I forgot the 1 here when we reduced it, and that's where the 1 is coming from up here, TJ, but I'm just going to follow through to make sure that that's what's going on, because we're solving for x. So I have to, these are my like terms here, so 23 over 108z subtract 108 divided by 4 equals 27, times 1 is 27. So 1/4 is the same as 27 over 108 z. X plus equals 1. Yep. And then 23 minus 27 equals negative 4 over 108 z. X plus equals 1. And then I'm going to add 4 over 108z to both sides. that cancels that out. So x is equal to 1 plus 4 over 108z, which is the same as saying 1 plus 2 over, oh, not 2, 1/27th, I think. 4 goes into 4 once, and 4 goes into 108 27 times. And that's what x is equal to. So that's where the 1 came from. Maybe when I was simplifying this on that other slide, I did it too quickly. Perfect, great. Now I can't go back in the slide, so I can't see it. Have to look at the recording, but that's where they get that 1 from, because we had to bring this over to the other side. But thank you for checking, TJ. That's great. So we did get the final answer was correct on that one. Well, it took the whole tutorial to go over this, but this is a good one to go through, because it did show about how to use non-squares, which is kind of like an application plus problem. We still had to use Gaussian elimination, and we had to deal with an answer that had a variable in it, because normally our answers don't have a variable in it. So that was a great one to go through. Yes, Andrew, a lot of fractions. Had to persevere for that one. Toronto beat Cleveland. Oh, you're talking baseball, right? Yeah, basketball. Oh, awesome. Yeah, go Raptors. Woohoo. Sounds good. I think everybody needs a break from matrices, but thank you both, Andrew and TJ. This was another great tutorial. It's great to have you guys in. And I will see you next week. Oh, I wanted to say before you go, what I'm going to start to do is I'm going to start to switch up. Our tutorials are going to stay on Monday, so that's not changing. But what I'm going to do is I'm going to go back and forth between a noon hour and an evening, just to get those students that aren't available in the nighttime. So next week I'm going to do Monday at noon, and then the following week I'll do Monday in the evenings, and I'll set that up on the calendar so we have that. If you are not available in the evening for the week that you want to attend, let me know, and let me know your questions. Just like TJ, you did tonight, you sent me that email about with this question on it, and I'm happy to go over it in the tutorial. Are you guys able to do a noon hour? Andrew, how are you during the day, or do you work?
I'm pretty flexible. If it's a noon is something I can make work.
Okay, perfect. And TJ, you're too busy at work, so so definitely try and send me questions before Monday, TJ. If you have, and also this week, we have a long week ahead of us. If you get questions, either of you, or anybody that's listening to the recording as well, so those of you that are watching another time, please send me your questions through that Ask Your Instructor or an email. And if you want me to show you in a video rather than a solution, just ask, and I'm happy to do that as well. I know videos sometimes are more helpful, and sometimes writing it in a solution is helpful as well. So just if you want to specify, that's great as well. Well, have a good night. Andrew, are you okay? Do you have any more questions? TJ's raring to go watch basketball.
I'm fine. Enjoy the game, TJ.
Awesome. Thanks, guys. Have a great night. See you next week. Bye.